PhD and how you became.
Yeah. Well, Kiara, thank you so much, and thanks for the introduction, and also thanks for inviting me here. This is great. As I said, I was wearing my MSU mask, but I walked around campus yesterday, so I bought a new mask that I thought would be appropriate for my visit here. And you know, I hope that I'll just give you a quick overview of some of the things I've learned and just, you know, as a scientist, kind of growing up in the science world and the academic world. And then we can have a discussion. A lot of times I like to hear from all of you about, you know, what are you doing? How did you get here? You know, how did you end up at, you know, Penn State University, and where do you think you're going? You may not know where you're going, but it's always interesting to see what the networks or the connections or how people ended up where they are. A lot of it's an unknown, convoluted pathway to get where we're going. So I named this title a while back when I talked about, I started thinking about my life, and I was thinking, yeah, you know, I'm a swimmer, so maybe that I thought about this analogy, but I was thinking, yeah, you know, a lot of times you just have that sinking feeling, man, everything's going wrong. Whether it's classes or grants due or whatever, I don't know, all the students are knocking at your door, or, you know, and so you're just, you know, you're like, okay, man, I'm sinking here, or what's going on? The next moment, you're getting there. You're swimming hard, your stride is good, you're making progress, right? And then those great moments when you're just floating along and everything's just gorgeous. And that's how, you know, I think about some of my career, you know, going through life is sinking, swimming, floating. And I work in 3 areas that intersect. I've always been interested in new technology as they apply to sampling the environment. I'm very interested in data out of the environment, so that, of course, intersects with how you're going to develop new methods for new things that show up. And then how do you interpret what you find? In my arena, I'm a public health water microbiologist. So how do I say what the risk is? What do we do with that information from a public health perspective? So next slide. So I grew up in Southern California in the high desert. It's a cold desert, a small community. I had a chemistry set and all those kinds of things, you know. And so you end up going from, I went from California to Arizona to Wyoming, back to Arizona to Florida to Michigan. I had a stint in DC with AAAS. So that was sort of my pathway. It doesn't look like it follows anything. It's just, you know, kind of jumping around. But, you know, how did I end up where I am now, maybe with this broad collaboration around the world and some of these accolades that are a result of my collaborations, really, and working with my students? Well, I think that following your passion, you may have heard this before, trying to find what that passion is and following it. Ask for help. I've asked for a lot of help. I still do. You would think I give out help too now, more than I ask, but I still have to ask for help. Always advancing my knowledge, because every time you go into a new, probably just diarrhea, right? The whole array of viruses, the whole array of bacteria that might be found, some of the other protozoa. But what we found is that, of course, we've got a lot of acute disease, not hepatitis, waterborne respiratory disease, but there's a lot of chronic disease. And I looked back in the literature at the Civil War, and they kept records on who got sick. And so when these young men got sick with mostly diarrhea, but they had dysentery, they had measles, they had all kinds of things going through the camps very rapidly. But there's another data set that they kept track of, and that was all these chronic diseases that were associated with these young men after these acute infections. And we didn't really used to realize they had all these chronic. And I think we still don't recognize everything, because there was also a lot of mental health implications in the database. It could have been because of the war and the horrible conditions, but it's not clear that we really understand all these chronic conditions that come after our infections. Next slide. you can hit through that. Viruses, we have a whole group of viruses, bacteria, of course, protozoa, and the helminths that we're concerned with now. And that we know that our indicator system won't work for. Go ahead. So my evolution also not only changed the environments I worked in, but also changed the type of organisms I worked with. So, I started out and was trained as what was called environmental virology. And I moved then to cryptosporidium. I always kind of joke when cryptosporidium came on the scene, I was doing wastewater reuse with viruses, and Giardia was showing up. So I was learning about the protozoa. New methods were showing up using fluorescent antibodies. And all of a sudden, this new protozoan was on the scene, this cryptosporidium. And so I always joke that cryptosporidium was also one of my mentors, because I learned as much as I could about, so, when I go to the parasite meetings and work with the protozoan scientists, they're like, she's not a protozoologist, but I knew a lot about crypto. I studied everything about that organism, and started looking at it. It had to be waterborne. There had been one little outbreak by the time I started working on it, but it was a norovirus was part of the outbreak, so they didn't think crypto was causing most of the disease. And so during my first break, one of my first grants on crypto, there was a major waterborne outbreak caused by cryptosporidium in Carrollton, Georgia. From there, with the molecular tools that emerged, and of course studying crypto was a whole new methodology from viruses. Started looking at source tracking markers, using molecular markers to look at the source of the fecal pollution, which had always been an issue. When you found E. coli, you didn't know where it was coming from, and that would always been a question next. So I evolved into the type of organisms I was going to study. And when I got to the Great Lakes, there were some significant water quality issues. And there was a very large group of scientists that worked in the Great Lakes, aquatic ecologists mostly. And they were looking at fisheries and aquatic ecosurfaces, but not so much public health. But all these things started to converge. Really, the sewage was less treated up there because there's a lot of water and they still use dilution. Combined sewer overflows where untreated sewage was discharged. A lot of stormwater coming off of ag lands with non-point source pollution. We didn't have enough, we had very poor infrastructure on the wastewater side. And then, of course, there was invasive species and algal blooms and climate change all impacting the Great Lakes, and a pretty important ecosystem shared by about 9 states. Go ahead. Next slide. I started studying using human markers, septic tanks. And so I think that as I looked at the new technology for source tracking, some of the methods I didn't think were going to give us very much information to help make decisions. And so we finally ended up using research or an approach that was developed by Kate Fields out of Oregon State University. And now, 20 years later, this is the approach that's being used globally. So it's host-specific markers. We have a marker in the human genome of the Bacteroides, in which we can track specific human fecal pollution. So that means it's coming from wastewater treatment plants, coming from septic tanks, sludge, or septage, right? And so we did a big study, with hydrologists and water chemists and land use planners. We looked at 80% of the drainage in the lower peninsula. This is all wastewater plants. These are the septic tanks. And we were able to map the human marker. It didn't correlate with E. coli, but it did correlate with septic tanks in the watersheds. So from small watersheds to large watersheds, and the wastewater treatment plants were discharging the marker too. But there was no correlation between increasing human marker and wastewater treatment plants or flow. And what we found was that, there was a correlation here. And it really got the attention. It was surprising how fast it got the attention of the state. The state didn't have a sanitary code. it got the attention of the septic tank industry, and the septic tank industry in Florida was mad at me. But now it took about 8 years before I pissed off the septic tank group in Michigan. But at any rate, this tells us, where we've got hot spots in terms of probably septic tanks being the source. And it turns out that when we looked at the nutrients, they were probably a significant source of some of the phosphorus that was also impacting the hazardous algal blooms. Next slide. So I collaborated a lot. We started looking at animal markers in non-point source. I'll just show you the top, the middle, and the bottom are low flow. That's in the winter, and things aren't flowing that much in the winter in Michigan. The cow markers on the left, pig markers on your right. And spring melt, we saw a little bit more positive of the marker. And then by the time the summer rains came, the marker had spread to almost every watershed that we looked at. So, surprisingly, the pig marker is very stable compared to the bovine marker, so there's some stability issues. But we could start to look at these hot spots in watersheds. And of course, climate and rainfall was a big driver. So the land was the source and the climate was the driver. Finally, we're thinking about all these things, and I was thinking mostly about floods. So if you go to Lloyd's City Risk Index, they measure risks to 300 some cities around the world. And they estimate, they're an insurance, they look at what the risk is to communities, from different disasters. And so I was always interested in the flood issue because at $432 billion being associated, and that was just with damage. It wasn't even quality changes or, they weren't taking into account some of the disease that came after floods. But I thought it was really interesting then, they had this pandemic down here. They put $591 billion if there was a pandemic. But actually, I think we know now that was probably an underestimation of the impact of a pandemic. Next slide. So, start new things. Coronavirus, the Coronaviridae family. That's not an enteric virus. I didn't know that much really about that family of viruses. It's an RNA virus, so it's very much like some of the viruses I had studied. But of course, as we all know, and this is probably the most well-recognized virus now in the world because it gets on TV a lot, it has these glycoproteins and this envelope layer. It's really found in a lot of humans and animals. It affects over 200 different hosts. So the family is quite broad with a lot of viruses, a lot of variability in the genome. The first coronavirus was identified in 1932, the common cold, right? And of course, SARS and MERS, which had global implications, are part of this family. But the interesting thing about this new SARS, right, SARS-CoV-2, was it was found in feces and found in sewage. Next slide. So we began monitoring in the campus starting in 2020. I think we took our first sample in April. We moved to developing the methods, perfecting the methods, working with the global community, really. So all the environmental biologists reached out to each other. They produced a consortium. They got funded in the United States. They got funded in Europe. They started some other consortia. So I can't tell you how many meetings that were global, where somebody was up in the middle of the night, like 3 in the morning, and somebody on the Zoom was up at 3 in the morning at these meetings, They were really dedicated. And so we started looking at the sanitary sewer, and on Michigan we learned that we had to streamline the methods, we had to get the results out faster. But this is kind of what it looks like. This is January through June. You can see the colors. Mean higher concentrations, the green is negative. And basically, one dorm was positive as soon as the students moved in January, at the beginning of this year. And then it kind of moved around, and it stayed pretty consistent. We had some hot spots show up in March around Super Bowl, and some other things that happened. Restaurants opened 50%, and we could see a correlation with that. We were also monitoring the community. And then the students started leaving, And you know, the cases started coming down in Michigan, and we started seeing the wastewater go to negative. Next slide. Now this is what it looks like now through the summer. It was pretty much negative. Over here, these are new locations we've just added for the start of the semester. These are the community locations that we've added, so we're monitoring what's happening in East Lansing compared to what's happening on the campus. And you can see pretty much negative or very low values. Had one big high value, but it wasn't sustained until we got into August. The students started moving in here. More students, international students, moved in here. Students moved in, and this is where we are now. We've got a mandate for vaccinations. Right now, we do not know how many people are vaccinated in each dorm. We're getting that information. There's a survey. So of the survey, the people that took the survey, 90% had the vaccine. But we don't know what the vaccine level is of those people that have not taken the survey. So we have a big percentage of students that have not taken the survey yet. So is this reinfection? Is it infection in the unvaccinated? Is it going to be sustained? You know, we start getting sustained infection and transmission, or is it just going to be a one-off? And so it's been interesting because in this case, we're starting to work with the clinicians on the campus. That's very different for me, working with the clinicians. Epidemiologists, of course the engineers, and the engineers that run the campus system. And of course the communicators at the university. How do we communicate this to both the students and to the public about what we're doing and what it means? So it's been quite an interesting new endeavor for me, I have to say. Next slide. We started a global collaboration that is trying to gather all the data that's around the world. And this has been quite a challenge. As somebody, you know, we were talking about data science earlier. You know, big data, data science, and this is global data coming from all different kinds of labs, different quality, sometimes different units. It's really amazing to look at this data and see can we make sense of what's happening globally. Next slide. So I'll just leave you with a couple more thoughts. You know, take opportunities if you can that come your way. If they, you know, if they follow your passion and you want to do them, and even though you're kind of hesitant because it might be difficult, you might have to juggle things like kids or something else, but if you can take those opportunities, take them. They're really going to be helpful. Always learn from your colleagues. And I learned from my students. I would never have done any metagenomics for viruses if it wasn't for, you know, my colleague, my PhD student from Korea, and then one of my postdocs who's now at Tulane, who came from Singapore. And they were instrumental in saying we should really, the new techniques, do a deeper dive into viruses, and we're going to learn more. And so it's been great to have these experiences and be part of this global community. Next slide. There are trials and tribulations in your career, and you don't think they're going to show up, but they do, and that's when you need to ask for help and figure out how you're going to address them. I've had a proposal plagiarized that I had to deal with a foundation. There was a lawsuit. I was part of a lawsuit at the University of South Florida that some people liked, some people didn't like, for women's salaries. There was retaliation because of some of these things. So, you know, you follow your heart, you do the right thing, but you're going to have these kinds of trials, I guess. And I always got help. I have to tell you, I never faced any of these things by myself. Next slide. Finally, you know, I always get asked about balancing. I have 2 children. They're grown now. I have 4 grandchildren. And, you know, maybe I'm not a good person to talk about balance because I'm like, I don't think I balance things that well, to tell you the truth. And I kind of saw it more as a teeter-totter than just balancing. So I always use this analogy because And then somebody, I mean, the young people, there's a lot of young people in here. They didn't know what a teeter-totter was, so I put a picture on there. It's like, what, did you get on a teeter-totter when you were a kid? You know? So you need somebody on the other end, right? It's not fun to balance. It's more fun to go up and down on a teeter-totter. And you do have ups and downs, and sometimes you hit the ground too hard. Either someone gets off, or someone pushes too hard on the other end, or whatever. And you're doing all the work, but maybe the next time they're pushing you up. And I really think you should play and share your life. If you're passionate about your work and science, it's a big part of our lives. And so how do we share it with our family and friends who may not be scientists? So my last slide is my family, I think. I have 4 grandchildren. And my kids still remember me taking them to wastewater treatment plants. And my mom has carried my pump down to waterways when she was younger. She's 95 now, so she doesn't. I don't ask her to carry my pumps. I don't carry my pumps anymore. You know, so they've traveled with me on occasion to meetings. They've come to me with me when I've gotten awards, and it's just been a great joy to share. Even though some didn't want to hear, you know, about all my work ad nauseum, but it's been a great joy to share my life with my family and my passion for water. So I think that's it. That's the last slide, and now we can have some discussion.
Thank you, Joan. Thank you. That was very, very good and inspiring, I think, for a lot of folks. So, questions. Let's open to questions from the audience here first, and maybe
the Zoom audience,
exactly.
I guess they'll text. They will text their ideas. Maybe we could just go really quickly and through the audience here, and you could just tell me quickly who you are, how you got to Penn State, what you're doing.
Sure, yeah. My name's Cody. I grew up in California as well, and I went to undergrad out there. Kind of a smaller school, but they had a pretty good energy program.
Oh.
So I went there for undergrad and really got kind of interested in the energy field, specifically with electricity. So I worked for a couple of years after that, and then decided to come back to grad school with Kiara. And so I'm a Kiara student, came back here, and I've gotten very interested in
and you knew this was the place to be for energy, huh?
Yeah, I mean, it's definitely one of the big ones, I thought. So,
good for you.
And I'm glad I came out here. I found electricity markets, like kind of this field of policy analysis, to be very interesting for me. So I'm glad I'm here.
That's fantastic. How about you?
Yeah, my name is Jiaxin, and I'm from China. I had my undergraduate, master, and PhD in the United States. Then Kiara is my advisor again. So my major is economics before. Then now it's like the field about energy economic, especially for electricity markets. And we are in the same team.
All right, fantastic, fantastic.
So my name is Lucas Andres Montes Herrera. So I was born in Mexico, but I moved to the U.S. when I was 14.
Okay.
I've been here ever since. So I did my undergrad in Texas. So from Houston. So I grew up in Houston and I moved to Austin. Now I'm here in Pennsylvania. This is my second year of my master's. I'm in my master's in international affairs.
Okay.
Yeah, so I wanted to come here because I honestly wanted to have a better understanding of water, but also just kind of how policy has to work in place, because I am interested in policy and I'm interested in energy. My major is in international affairs. I'm very focused on the ability to understand policy and why is it important to listen to the people that know what they're doing.
So, and what's happening globally with the market.
Yeah, it's not just the market, but just because listen to the people that know what they do, but at the same time, the public doesn't know.
Did you get here because of a person or because of the institution's reputation?
I mean, do you want my honest answer or you want the answer you want to hear?
Honest.
All right. Honest answer is because I was looking for international affairs and I applied for a bunch of institutions, and Penn State offered me the best deal for my buck.
That's good to know. I mean, these are things we need to know too, because we do think in our own institutions about cost. We think about it, our reputation, right, as an institution. Part of that is built by our faculty and what our students, and they graduate and they go out. That's our reputation. But the other is how do we accept a diverse group of students? How do we have diverse programs that interest people? And how do we get a good, cost, a good bang for the buck, right? So it's important to know that. Thank you. How about you?
Hi, my name is Lauren Dennis. I guess I'm starting my third year of my PhD. I'm in water resources engineering, and I'm getting a dual title in climate science. And I got my master's at Penn State in meteorology and atmospheric science, but I'm originally from the University of New Mexico. I got undergrad degrees in environmental science and political science, and I came here actually because I had the opportunity to work on an interdisciplinary project, both in meteorology and with some folks in geoscience, measuring methane emissions from potential stray gas migration.
And was there a connection between New Mexico and Penn State at that time when you came from New Mexico out here?
No, so I came here because of the opportunity to work on that interdisciplinary project. My background wasn't in atmospheric science, but I had an internship in the field. So I felt like the opportunity to work on this interdisciplinary project would give me some grounding because it was in the more familiar geoscience side, but also I got to learn atmospheric science at the same time.
Yeah.
So.
Very good, perfect. Yeah.
Hello, I'm Zhang. I'm from China, and now I'm majoring in environmental engineering. The initial reason I chose this major is because in China the condition of the pollution in air and water is very severe. So I wanted to find a solution for them. And another reason is that I'm interested in engineering, so I want to combine these two aspects for my major. So I chose this major, and I found that I'm interested in this field, so I come here to pursue further study on this field. And now I'm focused on the hybrid air exchange and the biological treatment.
Did you look at a lot of different universities in the U.S., or you already had a connection here, so you decided this was, and you knew the program, so you decided to come here?
Yeah.
Very good. Hi.
Hey, thanks for a very interesting talk. My name is Joel Landry. I'm an assistant professor in environmental energy economics here in the department. I do work evaluating the welfare impacts of a large-scale environmental energy policy, and also work on the political economy and regulation. I had a long, circuitous route to get here, but here I am. Yeah.
You got a job, right?
They made me an offer I couldn't refuse.
Where were you before you came to Penn State?
I'm originally from Illinois, and I did my undergrad at SIU Carbondale. Did a master's under an ecological economist there, Herman Daly, at the University of Maryland. A little bit later, and then I continued at Cornell, where I did a PhD in applied economics, and then I came here.
Fantastic. I think we don't have enough environmental economic majors or things that, you don't find very many scientists in that area. I worked with one from Athens, she's in Boston now,
Oh yeah.
that did beaches, that, environmental,
Evaluation.
Economics, and they're very neat, but I think we need more of that interdisciplinary. Cool.
Yeah, we have a great, actually,
Yeah, it's attracting a lot
interdepartmental
of good
PhD
people.
program here. Yeah.
Fantastic. Hey.
I'm Meng Wang, assistant professor in environmental system engineering in this department. So you will be surprised to see there are two environmental programs in different departments. So yeah, my research is mainly on the environmental biotechnology. So I met Joe's mentor when I was a postdoc attending the QMRA workshop.
Yeah.
And so we just had our first QMRA paper published in 2019 and got more attraction last year.
Yeah, exactly.
Yeah, so yeah, when I applied for here, I was not sure if I'm a good fit, but when looking into it, I find such a good opportunity to especially connect with people from the mining engineering or the petroleum and the environmental or the energy policy. So I just feel there's a potential opportunities to bridge the interdisciplinary work. And but there's also challenging as I'm the kind of the lonely one here. But it's good to have also other colleagues in different the departments, colleges, foster good collaboration. So
yeah. Is it harder to start collaborations under Zoom? Under our Zoom meetings now?
Yeah, I think I'm a little bit lucky. I started in 2018, so before so I have at least 1 year before the pandemic to meet people, so that's some connections.
That was good. You knew what they looked like, at least without masks, right?
Yes.
Hi. Oluwayomi Awe, I'm a Nigerian. I have background in chemistry. I actually worked with the space agency back in Nigeria. My interests are in the removal. Okay, I originally said I want to join the force for the good to remove or as much as possible reduce the gaseous pollutants from the atmosphere to give us better health. So I made applications to the department and I was pleased when Menk called me for a Zoom meeting and was like, would I be interested in working on biological nutrients removal in wastewater? I said, wow, well, yes. This is one of the greenhouse gases that we want to, as much as possible, take away from the atmosphere. So yeah.
Did you come straight here from Nigeria, or were you already in the U.S.?
No, I came straight from Nigeria.
Okay, so it was a culture shock.
Well, my brother is actually here in Connecticut, so I've had a lot of news about the United States. But then you had to get a coat. But then I have an adventurous mind. I want to see what is happening on the other side. So
fantastic.
Given the opportunity, here am I. Let's do it. We are here for all of it.
That's good. You know, in some cases, I like the idea that we recognize there's a support system when we go places. That's there, family or other people that we know. And that support system is also really important, you know, when we go out to start something new. Hi,
I'm Dean Morgan. I'm the Associate Head for Undergraduate Education for the whole department of EME. I'm also I also teach in the P&G group here, the Petroleum and Natural Gas Engineering group.
okay.
So I also have a long circuitous route getting here. So I started in UC Santa Cruz and got my BS in Earth Sciences there, and then went to grad school in Civil and Environmental Engineering at Tufts University and got my master's and PhD there. Met my wife, and then we both went down to Duke. I was adjunct there for a couple of years, and then came up here. So that's
fantastic. Yeah. Us California transplants.
Yeah.
I can't say I'm from California anymore.
I know. Still miss it though.
Yeah, go to visit. All right, so are there some questions from the Zoom guys? Or some comments, or the Zoom audience? We always forget about the Zoom audience. So what questions do you guys have?
Yeah. Questions that you have?
Yeah, I've got a question. So I can imagine that along your route you had many sort of opportunities presented to you, and I think it was great advice to take all of the opportunities that are placed in front of you and sort of have an open mind. But I'm curious if you could sort of give us some advice or insight about how you chose different opportunities. So for example, moving to cold Michigan or moving to other places. Yeah. I think all of us have circuitous routes, but it's interesting to me to hear sort of the decision-making process along the way.
Yeah. And in some cases, I wasn't very discerning, and I kind of learned the hard way. I think I learned lessons along the way, let's put it that way, when things set, I'm like, oh, I'll try that, I'll try this. So, if you're really adventurous, then, then maybe you get too much on your plate, or, I really like collaboration, so I have had some collaborations that were disasters. And I was thinking of writing an article about my disastrous collaborations, like, know when to hold them, know when to fold them. That was going to be the title of my collaborations in my career. Like that, because I've learned then, these are the criteria or characteristics for me that I need to have to make it work. And I didn't know that before. And some of these other decisions, I would ask my mentors. When I finally thought at USF, I was full professor in the marine science. The work was great, the lab was great, the students were great. I felt that I wanted to do more interdisciplinary collaborations, build bigger programs, centers, things like that. And I felt stymied there, so I started kind of looking at jobs. And once I started looking at jobs, I got a few interviews, and then I thought for sure I knew I wanted to move, but I kind of thought, I don't think I found the right place, so that was a gut feeling. But then when I got some offers that I thought maybe were viable, I called my mentors. I called Rita, and I have some mentors I work a lot with the water business, with the water industry, and consulting engineering firms. So I called some colleagues that I trusted to talk to them about the water business in these different parts of the country, and what it might be like to move from Florida, where it was, I was very established, the water district, water management districts gave out money, very established the wastewater reuse industry. Michigan did not have reuse. I don't think they know what reuse is. They have too much water, maybe. I think they reuse 1% of their wastewater on, highway rest stops. That's where they use their wastewater. Otherwise, it goes in the rivers and eventually goes in the Great Lakes. So there were so many changes, and I wasn't really sure about what I might face. So, and then of course I talked to my family. So my kids were going out. My daughter was already in the university, and my son was going to be a freshman. And he didn't like it too much because he's like, well, he was going to Florida International. He played soccer. He got a scholarship there. We were in Tampa, and he goes, well, now if I come home, I'm not coming home. I got to go to Michigan. What's there? I won't have any friends up there. You're just going to be gone. And I'm like, we'll give you our address when we move. It's not like, you'll go off and you'll come home. You won't know where we are, So he was not very happy about it. Rachel was, I think, somewhat okay, but my husband was like, yeah, let's move. He was like ready. It's like, let's go. And he goes, well, what about the pros and cons? He goes, what? Oh, okay, what are the pros and cons? He goes, okay, let's stay. And I'm like, oh, hell. No. So we had these discussions, but I used both my mentors and my family, and then, then you do your interviews and made a gut, made the call, But that was the process, I used. And I did try to learn from my early, mistakes of reaching out to certain opportunities. And it's really hard to back out of things once you've said yes, you're on a board or a committee, you've said yes to things. And then you're like, oh man, there's no exit strategy. So then I was always thinking about how do I get out of something that I got into that gracefully. Like, is there an expiration date? And if there's not an expiration date, how do I create one? That kind of thing. So some of it was, trial and error. Thank you. Yeah.
Speaking from my experience, I don't really know how it works here. But then most of the research work you have been able to do and your findings and the likes, they've been easy for you to communicate to the government, and when you communicate them to the government, they've been able to take cues from them and do the necessary things, like make the necessary corrections and implement them.
So I think in water science in particular, and probably, and I see this in environmental engineering as well, you're really part of this bigger network of things that are happening, the network of things, or whatever you want to call it. And so your research is never going to be in isolation. And so I do think we need to learn more about communicating our science. And I did do a stint with the AAAS in Washington, D.C. And right now it's a year. It's a whole year. When I did it, they had a summer fellowship. And I took my kids. I had to get daycare. And I took my kids up there. And So I worked with EPA. You choose the agency you want to work with. You write a proposal. It's competitive. But you learn about policy, the interaction of your science with policy. And so if there's some of those opportunities where maybe it's a workshop, maybe it's something that's in more duration, longer, a year or a month or a semester or whatever it is, and you're interested in it, see if you can, take that opportunity to learn. Because I learned so much about the workings of DC policy. I took an environmental law course when I did my PhD. The law school didn't really want me in there very much, but they couldn't, they accepted me in as I didn't have to do a grade. So I could just sit in on the class. And because I kind of wanted to know some of that, but I learned a lot more about what was a law, what was a rule, and the rules, what happened so I learned a lot about the Clean Water Act and the Safe Drinking Water Act. And in fact, from that knowledge and the work that I did work with Congress on the reauthorization of the Safe Drinking Water Act after the cryptosporidium outbreak. And so I got involved in these little government things that I didn't actually anticipate. But I had some knowledge of it because of those two things. I'd taken a class, and then I had a summer in DC. And in EPA, they teach you, of course, about the rulemaking there and the links to the different laws that have come from Congress. But you also get to go around to the different agencies and see what they're doing, the NOAA, USGS, the other federal agencies. So that was a real education for me. And I think then, because my science, then I started interacting particularly at the state level in policy, more than at the federal level. And then I had some more with DOJ. That wasn't very pleasant, actually. I have a lot of stories about lawsuits and working with the Department of Justice. Oh man, so that's another lecture about doing getting into court. My favorite stories, a few of them. So it was those kinds of things, and again, I was saying I kind of learned also by my mistakes. So you're always going to make mistakes, and so I tried to always learn because I would make mistakes in either communicating to the public so they didn't understand what we were doing, or they got upset, and then the engineering, don't let Joan talk anymore about public health risks to the elderly in Sarasota, about viruses in their groundwater, this kind of thing. So, I learned about it, but I'd say that I've had interaction from the legislature. I was on committees. I got then opportunity to serve on science advisory boards. So science advisory boards can be everything from like your local nature conservancy in your state to national, like EPA's National Science Advisory Board. So I've served on, all of those kinds of different kinds of boards. And you learn from the other people that are there, you learn from the organization, and learn how your science can maybe play a role in development of rules and policy. And so, those are the kinds of things that I did to get involved. So it's education, training, and then jump in at the different levels. Generally, when you don't get asked at the federal level to help until you've got, when you have, and I say this, it's really what you write down. Because people didn't know me. They knew me from what I'd written. They didn't know how old I was. They didn't know what I looked like. They knew I'd written a lot of work on cryptosporidium. And so when cryptosporidium influenced the reauthorization of the Safe Drinking Water Act, after the outbreak, the act was being reauthorized by Congress. And it turned out that Bill Young was the congressman in charge of writing the bill in the House side, and he was in St. Petersburg in Florida. And so that's how I first got invited to work with the legislature, with Congress on language that goes into a law. So it's really important that you just do write. You write down what you are, that demonstrates your knowledge of the science, because you just never know. No one was going to predict a cryptosporidium outbreak in Milwaukee, right? Just like not too many people predicted the extent of this pandemic we're in now. So, get your published works out the door, get some education, get some training, and then be prepared to join some boards and some committees, and eventually you'll gain that knowledge and gain that expertise.
Thank you.
Yeah.
So you mentioned you worked with the legislators. So this past summer, my internship, I was working in the U.S. federal government. I was working for my representative, ranking member, Kevin Brady, Ways and Means.
Okay.
And specifically, I want to refer you back to the infrastructure bill. An infrastructure bill has to deal with a lot of the Western United States water crisis that it's experiencing right now. I know your focus is in virology, but I'm just kind of curious as to, you did mention that you've worked like in the past, you've worked in Arizona and California and New Mexico. I had to do the research like on the infrastructure bill personally. Like I had to like go because my focus is in, I really like energy, so I had to research that.
Right.
One of the key things that I do have to mention about water is like the U.S. does not necessarily have like a federal mandate. It's up to states to like to effectively manage their own water, but at the same time though, there's no such thing as a massive recycling of like water programs.
That's
like
right.
Wastewater.
It's at the state level.
And it's at the state level. And I think, from my own personal view, I think it's a very haphazardly way of wasting water, in the sense that like we are not utilizing the water the correct way, and the water that it tends to be recycled is not used to be potable. Yeah, it's not potable. It's just used for the fields or for like grass or for like gardens.
Most of it is non-potable use. Yeah.
Which is why, and this bill addresses one of the major things is like it offers millions of dollars, and it offers like $1 billion grants of like programs that allow it to actively. So my question to you is, like given that the language of this bill is very broad, do you think that there is going to be that there can be do you believe that there's more effective ways to actually tackle like this sort of like water crisis that are being like happening? I know it's virology, but like water is a massive problem, and potable water is a very important issue, like especially in Western United States.
Yeah, and we always argued, there was an argument for quite a long time about the Clean Water Act and the way it was written in terms of the autonomy of the state to implement certain activities. And while Safe Drinking Water Act had no teeth about watershed, it's really about quality of the water at the end and how you treat the water. And so watershed protection, or if you think about the one water issue, which maybe wastewater reuse falls into that, or stormwater management, that type of thing, is done with if the state has some initiative and some goals, because the Safe Drinking Water Act doesn't address it, Clean Water Act doesn't address it. And so it's always been a gap. And in fact, quantity-wise, in the West, which has driven a lot of money on reuse and other aspects, have really driven compacts between states because of management of the watersheds. So they do have these compacts. Some do better than others, but they're all quantity. They're all driven by quantity, and very few are driven by quality. And so there's only a few compacts. The Great Lakes does have a water quality agreement that has some teeth in it. It gives money to either side of the border for monitoring of toxics and things like this. There's no comprehensive, approach. And so there's been an argument for a long time that a new legislation that bridges the Clean Water Act and the Safe Drinking Water Act gives more federal legal approaches to management of water resources, because right now all the tools, the TMDL, all of those for watersheds are on the Clean Water Act side. So it's fragmented by state. And so this fragmentation, but there's always been a fear too that, and it's sort of the water rights, issues. It goes back to that legal history of water rights, and that if you own the land, you own the water. And groundwater, trying to get groundwater in there is even more of a mess, right? The groundwater's in the gaps too. So we do see some guidance coming out, and I think this guidance, like with the recreational waters, that EPA developed some guidelines on recreational waters, and the states started adopting them, and they got some funding with it. So we could have things like that where we have guidance, and I think they're starting to look at wastewater reclamation as part of the guidance. And you know, California is so stringent for potable reuse, whereas then you go to Texas and El Paso just put their reuse, their reclaimed water, potable reclaimed water injection system in without any testing and assessment. They're just like, okay, we're gonna use this technology.
Depends on what part of Texas. I mean, Houston area.
Well, Austin is a little bit more progressive, maybe.
Yeah, and I think the rest of the state would like to keep it like that.
Yeah, but it's tough, and you know, I don't think that we have a leader that I know of, and maybe I think maybe we have more leadership, and maybe you can address this. I think it's fantastic you got that internship. But in our legislatures, like we used to on the environment side. So we used to have some key legislatures that they've retired or they've died. And I don't see new voices. There's a few, maybe, you know, there was one from Maine and a few here and there, but we don't have those strong voices anymore on reuse and protecting the environment. You know, and
well, more than anything, the reuse and protecting the environment has been tied up a lot to the state level, because it is the state that encourages the development of, like, you know, if we're talking about the environment, well, and we want to look at energy, most of it is up to the state to like develop, like, you know, the massive quantities of energy, and it's also like, you know, it's also like the high cost and everything that is it. And for the congressmen, or for congresspeople or legislative assistants to actively pursue that sort of like initiative to transform it, it takes a lot of political capital from back home and from people, because, you know, at the end of the day, they're going to look around and say, all right, now who pays for it?
Yeah. Now I think with all these floods and this climate, I mean, our problem out here is too much water and these weather-related disasters. And whenever you have these things, maybe we can take advantage of that. One of the things I'm trying to look at the infrastructure bill is whether there's money in there for research, science, and technology, centers, initiatives, innovation. Because if we're just going to give money to the city to build something, that doesn't invest in the future that we need, the 10, 20-year future that we need for this type of infrastructure. We got to have a long-term view, 50-year view for our water, energy, food infrastructure, right? And you know, we have these short-term views. So maybe there's an opportunity to get some of that in there. I don't know. You know, I haven't read enough of it. I asked my legislators to see whether they could find anything in that bill that was focused specifically on research, science, and technology.
Do you want me to point it to you?
Yeah, that'd be great.
All right, I'll pass you my email, because I had to do that. I literally had to sit down and comb through that.
Did you comb through the whole thing? I was like, oh man, I don't think I have time, and I'm gonna fall asleep.
I mean, when you work, when you're there.
Are you guys here for the discussion, or are you here for a new class?
Discussion.
Oh, good. I was like, they randomly came in. I was like, what is going on here? Oh, well, we all introduced ourselves. And we kind of, well, I introduced myself through a little PowerPoint, but everybody said like who they are, what they're doing, and how they made it here to Penn State. How did you end up here? So do you two want to introduce yourself? And we have another person that joined us. Oh, two more. Yeah. Go ahead.
Yeah, sure. Hi guys, my name is Hannah Chop. I'm a junior in environmental systems engineering, and my intention in coming to college was to get way out of Pennsylvania as far as I could, because I grew up in PA, and then Penn State just ended up being an economical decision.
We heard that before.
Yeah.
Very good. It's good to know Penn State's a thing.
Hi everyone, I'm Clay
Good.
Sauter. I'm also a junior in environmental systems engineering. I'm actually from Michigan, so I wanted to get out of state, but the program here is also really good, so it was something that I really attached to.
Far enough away, but close.
Yeah, exactly.
Close enough.
Yeah, so like Michigan State was one of my choices as well. So.
Okay, very good. Very good. Hi.
And one thing to mention, if I can just add, they are the two EME ambassadors for the program. And so we're happy to have them here.
Excellent.
Yeah.
I do have a class, but
Okay.
nice to meet you.
Nice to meet you too.
So thank you.
Okay, very good. Hi.
My turn? I'm Luis Ayala. I'm a faculty member here at Penn State. I just came out of class, so I'm sorry I missed. But the great news, I have lunch with you right now.
Oh, that's right. We can
so we can elaborate a bit more.
Okay,
I've
very
been
good.
at Penn State for 20 years now.
20 years, all right. Hi.
Yeah, I'm Liu, and I'm the PhD student of Dr. Wang. And I come from China. My research is about the carbon capture from the wastewater and nutrient removal of the wastewater, like the anomox.
And did you know, Professor Wang, before you got here? How did you end up at Penn State? Why did you come here?
Since I got the offer of Penn State.
You applied to a lot of different universities and then you got an offer here? Or just a few?
Just a few PhD, and I applied a lot of master. Yeah, and Dr. Wang gave me a chance to attend.
Okay.
Yeah.
Excellent. But you guys didn't know each other beforehand or anything? Did you know each other before?
No.
Never met? No?
Yeah.
Oh, well, you've got a good mentor. All right. Some other comments or questions? Anybody has?
How did you make the decision to kind of stay in academia as opposed to going out into the industry? Were there any specific reasons that made you sort of choose to stay in this field?
Yeah. So I think after I got my bachelor's, I was like, just need a break, really. And I was working at a VA hospital in research lab. And it was immunology. And quite interesting, but I was like, I don't like this as much. And I'd been working at B Lab, at the USDA B Lab in Arizona as a student. And my mentor there, she got her degree at University of Wyoming. And at the time, she was doing research on a bacillus disease, a disease of bees that affects the brood. And you could treat it with antibiotics. And so we were looking at the degradation of the antibiotic in honey, because you can't sell the honey if you treat the bees with these antibiotics. And so we were looking at whether if you stored the honey long enough, would the antibiotic degrade, or what happens with it if you feed it back to the bees, etc. So, and I got that job because of a friend. I was looking for a micro job because I was working at Taco Bell when I was undergraduate. And I'm like, I should try to get a job that has something to do with micro. So I was just calling everybody, and then one of my friends said, hey, there's a micro job at the B Lab. So that's how I ended up there. So she said, go to University of Wyoming and go to graduate school. She said, go, and so I decided I would go get my master's, and I tried to get into Oregon State. And they accepted me into the entomology program, but not the microbiology program. That was a very stringent program, and I don't think my GPA maybe wasn't high enough. Maybe it was 3.7 or something, 3.8 or whatever it was. But it was a very stringent program. And and then I applied to Wyoming too, and they had a small bee lab there. But they said, yeah, you could come here, we would fund you, and you could do your degree in microbiology. And at the same time, a new disease had come into the United States. It was called chalk brood. It was a fungus. And it's an old disease. So maybe I got my interest in chasing diseases through that, but this disease had come into the US, and it had been in Europe for a long time. So it affects the brood again, and it mummifies them, this fungus. And it had never been seen in the US before. So there was a mycologist up there. She was an ecologist. And she said she would take me on to mentor me. So I did my classwork in microbiology. I got paid by entomology group and worked with them. And I did my research over in botany. And I went to their seminars, and it was like, so it was very interdisciplinary. But I did know I wanted to be a microbiologist. And so, I didn't go and become an entomologist at Oregon State. I guess I could have made that decision and said, I really like Oregon State, so I'll just go become an entomologist. But I said, no, I like being a microbiologist. That's what I want to be. And so that's how I made that decision. And so I was in Wyoming for 2 years, and then I came back and I got a job at the wastewater plant. I was looking for a job and they were doing all their NPDS. It's a testing for wastewater effluent for discharge, right? And they were using most probable number. You set up all these tubes, a jillion tubes to look at the quality, of the effluent being discharged for fecal coliforms was the standard, 250 fecal coliforms. And I'm like, well, there's a new technique, membrane filtration. I think we should use that. That's a lot easier. And I'm thinking of myself because I'm like setting up all these stupid tubes. And so the utility in the state said, okay, you can do it, but you have to do a test and show that it's equivalent, that the membrane filtration is equivalent to the most probable number. So that's what I did. And then after that, and then I was thinking, should I get more certified as an operator and do more things at the wastewater and move up, right? Like, what are my opportunities? I kind of liked working at the wastewater plant, but sitting in a lab was not advancement. And then I thought, well, I really like working in research labs. So then I got a job with a new professor. I watched U of A until a new professor had come in, who was Chuck from Baylor. And they said, a new professor's there and we think he's going to have some money. So I went to see him. And he goes, well, I might be getting this grant. I might need to hire somebody. So I called, he says I called him every day and asked him if he got the grant. But I don't think that's true. It might have been every other day I called him. Yes. He goes, no, you called me every day, Joan. I said, no, I did not. We have a long discussion about this. We've known each other a long time. And I said, I think it was because I laughed at his stupid jokes. And I was sitting in his office like, this guy's crazy. And he had a lot of dumb jokes, so I was laughing at his dumb jokes. And so we have a difference of opinion on how I got hired there. But then once I was in the research lab and working, after I think a year and a half, I decided to do my PhD. And then I went on. So I kind of like, I want to be a microbiologist. Okay, I like working in a lab. I like research. Okay. And I was thinking about advancement, right? I was thinking, where am I going to be in 5 years, 10 years in this particular type of job? So, and then I just really liked the academic. After that, and at that point too, I had been thinking about invertebrate pathology, going back to invertebrate pathology from my B work. And I don't remember if it was Oregon State or another unit, because for some reason, I wanted to go to Oregon State. And then I had to say, am I going to stay in Arizona, because I've had a baby, and do my PhD here? I've got a job already. My husband's got a job. Or am I going to go and be an invertebrate pathologist? So water microbiology, invertebrate pathologist, so then I'm like, water microbiology. And then I never looked back. So I did have these kind of decisions, but for me it was like microbiology, research, lab.
Like the research part.
Yeah, and then being in the academic world and doing my PhD. And at the PhD level, like I said, I just had so many micro classes. I just took all these other classes. I took a lot of engineering classes. I took the environmental law class. I took a hydrology, that was hard. I took a hydrology class. And so I took a lot of diverse classes for my PhD. And then I just liked the students and I liked the environment, and I said, that's the way I want to go. But I still worked a lot with the water industry. And I have a lot of students that have gone into the water industry, either into research labs or operational labs. And those have been good jobs for them, good career paths. Some have been in California with Metropolitan Water District and others, so for LA Sanitation. So, yeah, so some good things there too. But that was my kind of pathway.
I have one question.
Yeah.
I was curious about the article, how to hold them and how to...
know when to hold them, know when to fold them. It comes from an old song, a cowboy song.
Which is fascinating, and I know you haven't written the article yet.
Yeah,
I was wondering if you could give us the abstract. Like, what are the key insights? And
yeah,
like,
I was trying to figure out like how you know, how long it should be, and that what would be the key messages, and thinking about my own relationships of like, you know, with Chuck Haas at Drexel University with the QMRA, and when I first met Chuck, and I thought the Q&A, but man, this framework is so important to what I do, and I didn't know anything about it. And I always joke that, yeah, I made him teach me some of the math. So, and we've had a long collaboration, Chuck Haas and I at Drexel. And so I was trying to think what were the characteristics there of the two partners. You know, one is always in more a senior role than the other one. And are you in a learning mode, or are you in an active mode of trying to write a grant together? Or are you learning from them right now, write a paper together? In some cases we wrote papers together first, and then we wrote our first grants. So there were little, and then I think then the position switched at some point where I took a leadership role and he took the more, you know, following role. So it's you find someone that is willing to be really flexible. You know, I think flexibility with good, you know, collaborators is one of the things. If somebody's really strict about, you know, there's an abstract deadline, and I think part of it is trust, because I think if you build that trust, there's an abstract deadline, the other person writes it, it's got to go in tomorrow. Do you have time to look at it? No, I trust you, put it in, you know. So I think part of that is the building of the trust. And then who's going to have which role. And especially in new disciplines, if I walk into a very new discipline, if that individual is not willing to teach me the lingo and help me and not just throw papers at me and whatever. You know, I've walked into places, later I walked in and I was like, you know, I'm like, I'm not going to collaborate with that person. I knew right away, because they weren't interested in me being integrated into the science, doing something that we both could do together, that we could both learn from. He used to say, oh, here's the papers, you could help me with this grant, blah, 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 right? And so I think there was some of that too. I need to articulate that better so that sort of, you know, lessons, or maybe it's, you know, principles that you can articulate, right? Because that's why I need to think about it a little bit more. And I also have found that there are toxic people. There are people in our arena, whether it's insecurities or whatever it is, they like to put other people down instead of build other people up. And you'll always find those people, and those are people who we have to walk away from. It's not easy to recognize who those people are initially when you start working with them. When you first work with them, they're all honey and sweet and, you know, everything's rosy. But over time, as you walk into their office, they're putting so-and-so down, da-da-da-da, this, that, and the other. And, you know, they're just kind of toxic personalities. For me, I don't like that kind of personality. And I don't like people that, you know, run their programs by, you know, I don't know if it's brute force or whatever it is. So it's some of its personality and style. And then you have to say, that's not my style. And I'm going to walk away from that kind of thing. So, yeah, those are some of the things off the top of my head. But I need to articulate it so it's more like principles and, you know, of how you might approach collaborations.
Thank you. When you write the article, please send it to me.
I will. Well, I'm getting some incentive to look at it again. I got with the title, and I got the outline, and I got the people I wanted to, you know, that I was thinking about my own relationships. I got that all down, but then I stopped. I did SARS instead.
Yeah, especially now there are more and more interdisciplinary work, and so you need like collaboration with the people outside your field, and so that's very important.
Yeah, and some I've had, you know, they've been finite, but they've still been really good. We've had collaborations for several grants, 3 to 6 to maybe 9 years. And then after that, the collaboration waned. We didn't get grants together anymore, but the friendship stayed. And we would talk about things. And I think when you have a joint, or if you're on a committee together, so you start doing other types of collaborations. It's not just papers and grants. Early in your career, it's about papers and grants. You know, that's what the types of collaborations I was looking at. And but then further on, it's more, you collaborate with somebody on a committee, or you collaborate with somebody, even on university committees where you're trying to look at governance and things like that. So there's all kinds of new collaborations that emerge beyond the scientific collaborations. Yeah. Okay, well, this has been fun.
Yeah, thank you so much.
Really enjoyed